So here's a picture which describes this question. So I mean, this is not a good enough picture yet. We need to figure out exactly what shape and what properties that we need to use. Okay. So, I mean, this light, I made it a little bit like, like a real light, but really what we're concerned about is just the center part, right? Just the perpendicular distance, exactly the perpendicular distance. So that perpendicular distance they tell us is 15. So from here to here, 15 feet. So let's consider the distance from here to here as he walks this way. Let's consider that distance x. It's changing constantly. Do I have to label this one like y? Is it changing as this scenario unfolds? Is the distance between the perpendicular distance between the the man and the light, is it changing? It's not changing, right?
No.
It's 15. So you don't need to call that a variable. Okay. Okay, so actually a searchlight is located on the ground. Initially, he's not here. I like to know what's happening here, but initially he's here. Somewhere on here. So that the distance between the searchlight and the man is not 15, but 20. Okay, so this hypotenuse length is 20. So now you can sort of see exactly what shape we're dealing with here. Right? Now, talking about rotation, how do you determine rotation? Is it a measure of length? No, it's a measure of angles.
Yeah.
So we're talking about this theta here. What we want to find is the d theta over dt, right? So let's measure this distance here to be x, not this one. When x is equal to 0. So it's certain length, it's constantly shrinking, right, as he walks towards the light, dx over dt. So therefore, they're giving you that he walks along 4 feet per second, but it's a minus 4 because distance is shrinking. Okay. So what relates this variable here, x, and this theta? What equation using this triangle configuration? Okay, so there's actually two possibilities, sine theta or tangent theta. Now this 20 is not fixed, right? This is actually always changing, so I have to call that like a variable, like hypotenuse, h, or maybe hypotenuse, maybe s, because h looks like height. So what's better? I want to find d theta over dt. I want that to be related to as little variable as possible, right? Is sine better or tangent better? Right. Tangent theta will be just x over 15 always. Now if you differentiate this implicitly both with respect to time, both sides, we get secant squared theta d theta over dt. You get 1 over 15 dx over dt. Okay. So when he arrives in this perpendicular distance, what's the angle theta? When he arrives here, this angle becomes 0 degrees, right? Okay. So what's secant of 0 degrees? Secant is 1 over cosine. You know cosine of 0 degree is 1. So reciprocal is still 1. dx over dt is given to be minus 4. So d theta over dt, at the moment when he approaches, is shrinking at 4 over 15 radians per think it was second, right? Yeah, per second. So it's actually radian. Not, I should have said not degrees, but 0 radian here. And I should have said radian here. But 0 radian, 0 degrees is the same. So it's weird because as he's approaching here, right? As he's approaching, it's going to be negative. But as soon as he passes through this point, it's going to start increasing again. Okay, so it's if it was an equation, that's called a critical point. So anyway, the angle is decreasing at -4 or 15 radians per second.